Hello, this is Mrs. Garple, and in this video I'm going to go over solving quadratic inequalities. The purpose for the graph is to help us see what we're looking for on a graph to help us identify which x values would be solutions to the inequality. So the first thing, because this is a quadratic, you want to have it set equal to 0. And I'm actually going to rewrite this problem so that it looks like that it's equal to 0 and not that it's an inequality to 0. And then you're going to you can use any of the methods for solving a quadratic, but I always like to check to see if it factors first, so that's going to be my primary method. If something doesn't factor, then you can always use completing the square and using inverses, or you can use the quadratic formula to find the roots or the x-intercepts. So when I'm factoring this, I am looking for what values or what numbers multiply to equal -10, that's the c value, that add to equal 3, the b value. So for 10, we have 1 and 10, 2 and 5. Those are our only pairs of numbers. Well, 1 and 10 are too far apart. 2 and 5 will work if 2 is negative. -2 times +5 will equal -10. -2 plus 5 will equal 3. So the factored form of this is x minus 2 times x plus 5. And I can identify my x-intercepts from these expressions. So if I want the x-intercept for the x minus 2 factor, x minus 2 has to equal 0. We can add the 2, and we know that we have an x-intercept at 2. And I'm going to go ahead and plot that point on my graph. I'm going to do the same thing for the other factor, x plus 5 equals 0. And then I'm going to subtract 5 from each side to find that my other x-intercept is when x equals -5. I'm also going to plot that on my graph. And those are the only ones that I'm being real precise about. I don't really need to be 100% accurate with my parabola that I'm going to graph. What I'm going to look at is the original trinomial, the x squared plus 3x minus 10, and I see that the x squared term is positive. So I know that this parabola is going to open up while going through those 2 points. Now I'm going to go back and take a look at this inequality. Keep in mind that the expression, the quadratic expression, is giving us the y values. So we're looking for y values that are greater than or equal to 0. When I look at my parabola, I'm looking for what part of my graph is above y equals 0. So the x-axis has y equal to 0, and I'm just going to mark that on here. The x-axis is y equal to 0. If we go above the x-axis, that region is y greater than 0. And if I look below the x-axis, that region is y less than 0. So we're looking for y to be greater than 0. That part of the graph is shown with these 2 portions. And if I think about the x values for the points on these 2 extensions of my parabola, the x value on the left side is going to be less than -5, and on the right side it's going to be greater than 3. So my solution for this particular problem has 2 parts. x has to be less than or equal to -5, or x has to be greater than or equal to 2. Because when the x values are less than -5, this is going to continue to go outward and up. When the x values are greater than 2 on this side, it's going to continue to go up and outward as well. So that's the region of our graph that we were looking for. That means that the y values that we want are going to be outside of those values. Let's take a look at another one. Here we have x squared minus 4 less than or equal to 4x plus 1. I mentioned with the previous problem we'd like to get this equal to 0. So I am going to go ahead and subtract 4x and subtract 1 from both sides. So we're going to have, and I'm going to go ahead and set it equal to 0 right now for my solving work. So we'll have x squared minus the 4x, and then I have the like terms -4 minus 1, which combine to give me -5. I'm going to look into factoring this first. So I'm looking for numbers that will multiply to equal -5, that will add to equal -4. Well, the only numbers that multiply to give us 5 are 1 and 5. So the question is, can I use 1 and 5 when I add to get a -4? The answer is yes, if 5 is negative. So 1 times -5, I'm just checking, will give me -5. So my factored form of this expression will be x plus 1 times x minus 5 equals 0. And again, for solving, you're going to think of each factor equaling 0. So if x plus 1 equals 0, that means x has to equal -1. If x minus 5 equals 0, that means x has to equal +5. And again, I'm going to plot those values on my graph. And then I'm going to go back to my original trinomial, the x squared minus 4x minus 5. It's a positive x squared. So I know it's going to open up and it's going to go through those points, slowly getting wider and wider as it goes up. Then, keeping in mind that the x-axis is y equals 0. Above that we have y greater than 0. Below that we have y less than 0. And that this trinomial is representing y values and we had moved everything to the left side. We're looking for y values that will be less than 0. So the equivalent of this trinomial, when I moved everything over, was x squared minus 4x minus 5. The inequality stayed less than or equal to 0. So I'm looking for y values on my graph that are less than 0. So again, looking at my graph, I see that this section of my graph that I'm now tracing has y values that are less than 0. The x values that go with these points are between -1 and +2, or +5, excuse me. -1 and +5. So our solution to this problem will be written different than it was on the previous one. Because the solution has x values that are between two numbers, I'm going to write x between two inequalities, both of them written as less than or equal to. On the left end, you write the lower value of x, and this can be read -1 is less than or equal to x, which is less than or equal to the larger x value, which is 5. So our solution to this problem is -1 less than or equal to x less than or equal to 5. And this concludes the video on solving quadratic inequalities.